Welcome pre-calculus students to class today on Friday the 11th. Hope you guys have enjoyed your 3 days off and hopefully your tests are done. Remember, there are point deductions, 5 points per day. For those that have not contacted me, some of you contacted me and said you had questions, but I've not heard from you as to whether or not you have finished your test. So those that have told me they're done, that's fine. Those that have not, I need to hear from you. That was a lot of time to get a test done, 3 days. So they should be finished by now. And today's our first video of the week on Friday. So hopefully you guys are ready to learn some new math today. And no quiz over the weekend. In fact, I'm actually getting ahead of myself. That's one of my announcements I'm going to make in a second. So let's just go ahead and jump into our announcements. I'm not sure if you know all this. Let me explain something to you. Our first quarter was 10 weeks long. Our second quarter is 8 weeks long. Now, usually in most schools it goes 9 and 9 for a total of 18 per semester. We did 10 and 8 so that our fall break would line up with Hamilton County, which is where my wife teaches. So that's why we've done it this way. And your parents knew all this way back in August. I emailed them all this information back then. Some of them might have told you and some of them might not have. But anyways, our 10 weeks will be over a week from this Monday, so about 9 more days, 10 more days of school, and then you'll get a week off. So be looking forward to that. It really would be nice. No quiz over the weekend, so don't get behind on your homework. You have a video today and homework to do. You have the whole weekend to do it, so please get it done. Don't get behind. And look at this next comment. Do you really want to have work to do over the fall break? I mean, really, your 7 days you have off? Now think about it for a second. You're going to come in here to take a test on Monday, let's see, 11th, 14th, 21st. Monday the 21st, I believe, is the date. And that's your last day of class until the following Tuesday. Okay? Now look, I'm really, I can tell you honestly from the bottom of my heart, I'm not upset, but I'm not sure how many of you watch the review sheet videos. I know a lot of you come in here with a lot of questions, but what that does, and that's okay if that's how you want to run the class for yourself, that's totally fine, but what that means on your fall break is you're going to have a test to take because you're not going to be ready Monday to take it, and you're going to spend the 2 hours asking questions, which doesn't bother me. But my advice to you, take it or leave it, is to really not get behind on any of the videos, which really you shouldn't do all year anyways. And then when I give you the review sheet next Friday or next Thursday, work on it, do the entire thing, watch the video, and then maybe come in here Monday with just 2 or 3 or 4 questions so that you can start your test, so that you can finish it that day while you're at my house. Now, if you don't do that, I am not bothered. You understand, guys, it does not affect me at all, okay? But I'm just giving you some advice. So that's basically it. Let's get ready to take some notes. Grab your notebooks, grab your books, pens, pencils, calculators, all the stuff that you need. Let's take some notes for a little bit. Okay, we're going to do some math today that involves starting with a trig statement. So you're going to be given a trig statement, and I'll show you in a little bit what they look like. We then take this trig statement and we manipulate one or both sides of it until both sides are the same. So we start off with a trig statement. We have an equal sign here. We have stuff over here. We have stuff over here. And they're different. Both sides look different. Even though they're equal, they look different. And then we manipulate this side, we manipulate this side, or sometimes just one side, and in the end we have the exact same thing on both sides. And that's what we're going to do today. We call this procedure proving trig statements. And that's what we're going to do today. We're going to prove trig statements. Now, unfortunately for students, there is not a step-by-step method to use to solve these problems. In fact, not only is there not a step-by-step method, quite often you will have to use a trial and error method. You'll have to make a substitution here or make a substitution there, simplify here, simplify there, and then in the end you'll see you didn't do it the right way or the way that actually makes the problem fall together nicely, and you'll have to start over again, okay? And I can speak from experience, these problems are really frustrating to a lot of students I've had in the past. So really take some good notes, really pay attention and listen. And I'll try to give you some tips and little situations to look for that might help you know quicker what to do in some situations. So now that I've got you totally excited about today's math, let's go ahead and get started. your heading today, please write this down. We are going to prove trig statements. So your heading today is proving trig statements, and it's lesson 6.3. And the date today, if you keep track of that, is the 11th. Today is Friday the 11th, okay? Proving trig statements. Lesson 6.3, and the date today is the 11th. We're going to look at 5 examples today. 5 examples, and then you will have, let's see, 3 through 29, 14 problems in your homework. So pretty standard. That's pretty normal. All right, let's go ahead and start with this first problem here. We have a trig statement, and what we're going to do is we're going to manipulate both sides or one side, either way, until both sides are identical. Now, whenever I see a parentheses squared, I'm thinking to myself, okay, I'm going to go ahead and write this parentheses twice and go ahead and do the multiplication. Now, the reason I'm doing that, students, is look over here. I have 2 terms, all right? 1, 2. And over here, I've got a parentheses to the second power. You know, I'm not even close to this. So if I can do some multiplying on this right side, it might actually make it a little easier. So take your sign and multiply it through. Now, if you do that correctly, you will get sine squared and then sine cosine. Now, take your cosine and multiply it through. And if you do that correctly, you will get positive sine cosine, and then cosine squared. Cosine times cosine is cosine squared. Now, look for little things like this, students. Notice I have a 1 over here on the left side. Do you see that? So eventually I'm going to have to get a 1 over here. Well, notice I've got a sine squared and a cosine squared right here. So put those side by side. So sine squared plus cosine squared. All right, cross those off. And now look here in the middle. I have a positive sine cosine and a positive sine cosine. They're like terms. I've got a 1 in front of this one, a 1 in front of this one. So combine those and you will get 2 sine theta cosine. And I apologize, this pen is freezing up a little bit. Cosine theta. Now, think about this. I'm going to go ahead and tell you right now on this problem here, on the first one, we're only going to manipulate one side. We're going to keep manipulating it until it looks like the left side. That'll happen. Sometimes you'll work on both sides. But look, students, sine squared plus cosine squared. Well, if you'll look at your Pythagorean identities, that equals 1. So I've got a 1. Now, if you will look at your double angle identities, you will see that sine 2 theta equals 2 sine theta cosine theta. So this whole thing right here would equal, bring down your plus sign, would equal sine 2 theta. And look at that. We did it. It looks just like the left side. 1 plus sine 2 theta. All right? Pretty cool. So in these problems here, do you see your answer is not what you get out in the end? I'm not going to check that on a test or a quiz. I'm going to check all of your steps and make sure that you're making right substitutions and right simplifications in order to prove the trig statement. All right, let's try another one. Now on this problem here, notice I have 2 fractions that are equal to each other, and I can't promise you this little tip will always work, but quite often it does. Whenever I have 2 fractions that are equal to each other, I'm just trying to get a little more space here. I've taught before in the past you can cross multiply like that, and then like that, and then set your 2 products equal to each other. And quite often that will help. Okay, now watch this. See this t secant t? I'm going to cross multiply that with this up here. So t secant t times 1 would be t secant t, and then t secant t times negative cosine t would be negative t secant t cosine t. All right? Now, if you got to back it up and watch that again, feel free to. I'm going to continue on. Now I'm going to cross multiply like this. So here we go. Don't forget your equal sign. Secant t times t would be t secant t. And then t times -1 is negative t. Look at that, we're doing really well. Now let me show you something else you can do. I've told you you can cross multiply, make substitutions. Look at the simplifying. Don't you have a t secant t and a t secant t? Can you not cancel them off both sides? If that confuses you, look at it like this. You know how you can bring a term over? Bring your t secant t over, and it was positive right here, correct? So when you bring it over, it's gone. It becomes a negative t secant t, and so they cancel out. I just like to do it like this. Personally, I think it's faster and easier just to say this. I've got a positive t secant t on the left side and a positive t secant t on the right side, so they just cancel out. So now I'm left with, this looks really hard, students. I've got a negative t, and over here I've got a bunch of stuff. A negative t secant t cosine t, but hold it. Come on, guys, think. Secant and cosine are inverses of each other. So do you see this secant right here? For this right here, for secant, I could substitute 1 over cosine. So now I've got 1 over cosine, then bring down my cosine, and really my cosine t I can put over 1, and then bring down your negative t. So I brought down my negative t, I brought down my cosine, and don't you see what's going to happen here? I made my substitution. Secant is 1 over cosine. Now look what happens. 1 over cosine times cosine over 1. They cancel, leaving you with 1. 1 times 1 is 1. 1 times 1 is 1. So 1 times negative t is just negative t. And of course on the right side we're left with negative t. So there we go. So sometimes when you start off with one fraction on one side and one fraction on the other, sometimes cross multiplying is a good method to use. Not always, but it's something to at least consider. Okay, let's take a look at problem number 3. It is a little darker. I hope you can read that okay. Okay, students, this is going to be a pretty tough problem, so here we go. This will take definitely quite a few pages. So bear with me and let's see if we can get this done. Now first of all, I'd like to point out to you, you have one term on this side and you have two terms over here. So more than likely in a situation like that, the smartest thing to do is to go ahead and get a common denominator and put these two fractions together. Now a common denominator for sine and cosine would of course be sine x cosine x minus, and then sine x cosine x. Students, I'm going to totally forget about this right side over here. I'm just going to do most of my manipulations to the left side, and in the end it should equal secant x. Now, so here's my common denominator. What do I have extra here that I don't have here? Well, a cosine x. So I have cosine x, and then bring down your numerator, sine 2x. Now, what do I have extra here that I don't have here? Well, a sine x. So let's put a sine x, and then bring down your numerator, cosine 2x. Now, next step, we can go ahead and put these together, I guess, very quickly. So cosine, actually, I'm going to go ahead and make a substitution first. This cosine, do you see the sine of 2x right here? That's a double angle identity, and I can very quickly substitute. I don't have these memorized like I should. Let me quickly turn to my book here. For sine of 2x right here, I can make this substitution right here. I can put 2 sine x cosine x. All right? And then all over my common denominator, and then minus, and then my common denominator. And now, here for cosine 2x, I can also make a substitution. So I'm going to put sine x, and then I have three choices. I feel like this is the best one to go with, and I really don't have a reason, except I just feel like this would be the best way to go. Cosine x minus sine squared. So cosine squared minus sine squared x. All right. Now I told you it's going to be a long problem, so just understand that and be ready for that. It's going to take a good amount of time. So, all right, let's go ahead and highlight this and move on to another page. And after this, we only have 2 examples left, and we're finished with the homework, or with the notes. All right, now watch this carefully, guys. Look right here. I have cosine 2 sine x cosine x. And so really what I have when I multiply those together is 2 sine x, and there should be an x right here, cosine squared x. All right? Now let's go ahead and put our minus sign, and we'll put a real long thing, put our common denominator. Now, sine x times cosine squared would be sine x cosine squared. And then sine x, now remember, it's going to be a negative. Okay, we have a negative sine x times a negative sine squared would be a positive sine cubed x. All right? So, take a look at that. Make sure you see what we did. We've taken the negative sine x, multiply it times cosine squared. Negative sine x times negative sine squared is a positive sine cubed, all over our common denominator. Now, please watch this, students, and think about this. I've got to break all of this down. And what I remember is that my denominator is sine x cosine x. So I said to myself, now hold it. If I split this back up now into 3 fractions, because I have 3 terms up top, 1, 2, 3, and then simplify each fraction, I'm probably going to be doing okay. So my first fraction will be 2 sine x cosine squared x all over sine cosine, and then minus, my second fraction would be sine x cosine squared all over sine x cosine x, and then my last fraction would be sine cubed over sine x cosine x. Now let's go ahead and move to another page here to get some more room real quick, so bear with me, please. All right, and let's continue on. Now, look at this first fraction, 1 term over 1 term. I've got a sine that cancels with the sine. I've got 2 cosines up here, cosine squared and cosine. Take away 1 cosine, take away 1 cosine, and you're left with 2 cosine x up top. Do you see that? Take away sine, take away a sine, take away 1 cosine, take away 1 cosine. That leaves you with 1 cosine right here, and you've got a 2 right here, so 2 cosine x. Now over here, notice we bring down our negative sign. Our sines cancel. Do you see that? And we have 2 cosines up top and 1 cosine here. Take 1 cosine away, take 1 cosine away, and you're left with cosine x. Now we come over here. Be very careful. Watch what happens. I can take 1 cosine away, all right, and take 1 cosine away from up here, so I'm left with sine squared. So now I have plus sine squared x. That's not sine 2x, not a double angle. It's sine squared x over cosine x. Now, these are like terms, students. Look, there's really a 1 right here. I have 2 cosine x minus 1 cosine x. 2 minus 1 is 1. I can put these two together. 2 cosine x minus 1 cosine x would be cosine x. So I have cosine x plus sine squared x all over cosine x. Now, don't get frustrated. Watch. Equals, let's go back to the beginning, equals secant x. So this whole thing is supposed to equal secant x. Now, I'm thinking, how in the world can I do this? Now, let's think this through for a second. Now, what I notice is I have 2 terms over here and 1 term here. So, why not get a common denominator, put this over 1, put these two together, and watch what happens. I have a denominator of 1, a denominator of cosine. A common denominator for 1 in cosine would be cosine x, cosine x. Watch how quick we're done now. Okay, notice I have nothing extra here that I don't have here, so I simply just bring down the numerator, which is sine squared x. What do I have extra here that I don't have here? Well, a cosine, so I've got to put a cosine up top. Plus, I'm bringing down a cosine from the numerator, so I end up with cosine squared. Do you see that? I brought a cosine up from the bottom because I had extra cosine. I brought one down from the top, so cosine squared. So when you put these two together, you really have this. I'm not going to open another page, so watch this carefully. Now watch. When you put these two together, you get cosine squared plus sine squared all over cosine. Well, now think about it. Think about your Pythagorean identities. Sine squared plus cosine squared, or cosine squared plus sine squared, equals 1. So for this whole numerator right here, you can just put 1 now. So I really have 1 over cosine equals secant x. And that's true. What is the inverse of 1 over cosine? Well, 1 over cosine is the exact same thing as secant. So secant x equals secant x. These are really tough problems, and I know that. And that's the third one. We only have 2 more to do, and we're done with the notes. But they're just, there's no step-by-step method to do these, guys. There really isn't. It's just looking at the problem, reasoning, substituting, simplifying, trying this, trying that. Some of these might take you a really long time, okay? But that is how you do them. Okay, let's take a look at problem number 4. I think we have one more after that, and then our homework. Yep, so let's go ahead and take a look at this one here. Okay, students, now when you look at this trig statement here, and this one's not as difficult as the last one, rest assured, not nearly as difficult, but look, you're either going to have to take one term, because they are multiplying, so it's one term. You're going to have to take one term and try to split it up into 2 terms, or you can take 2 terms and try to put them together. And that's always my preference. I always try to take 2 terms and put them together. So with that in mind, here's what I would suggest. Yes, you could put both of these over 1 and try somehow to put them together. But I think it'd be a lot easier if we made one of them a fraction. Let me show you what I mean. We know that tangent equals sine over cosine. So tangent squared will just be sine squared over cosine squared. Now by making that substitution, this for this, by making that substitution, now look what I can do. Now I can put sine squared x over 1, and now I can get a common denominator and put these two together. So I have cosine squared here, 1 over here. The common denominator for cosine squared and 1 would be cosine squared and cosine squared. Okay? Now, what do I have extra here that I don't have here? Nothing. So just bring down your sine squared x. And what do I have extra here that I don't have here? Well, a cosine squared. So you're going to bring up a cosine squared and then bring down your numerator, which is sine squared. Now let's go ahead and put these together and let's see what we have, okay? So we have sine squared x minus sine squared cosine squared all over cosine squared. Now please do not start canceling like this. You cannot do that because you have 2 terms up top, so please don't do that. That is incorrect. All right? But look what you can do to the numerator. Please watch this. You can factor out a sine squared and a sine squared. So now in the numerator, I'm going to pull out a sine squared in the numerator, and I'm left with 1 minus cosine squared all over cosine squared. Okay, do you see that? I put out a sine squared out of both terms, factored it out, and put a parentheses right here. And you're left over with, inside the parentheses, 1 minus cosine squared. Now, let's go ahead and pull this over to the next page right here. Now, watch what I'm going to do. See if this makes sense. Now watch. Please look at your Pythagorean identities. Do you see that it says sine squared plus cosine squared equals 1? Do you see that? Well, how about if you brought the cosine squared over and made it negative? Would you then not have sine squared equals 1 minus cosine squared? Do you see that? I'm just taking a Pythagorean identity and moving something over. So now I see that sine squared equals, oh look, 1 minus cosine squared, which is what I have right here. 1 minus cosine squared. So I can substitute for 1 minus cosine squared. I now have sine squared, and then I substitute in the parentheses sine squared all over cosine squared. And now, of course, the numerator becomes sine squared times sine squared is sine to the fourth all over cosine squared. Now, I've worked a lot with this side. Now let's go ahead and take a look at the other side. Let's go back to the original problem right here. Now, I had sine squared and tangent squared. Y'all see that right here? All right, sine squared and tangent squared. So I'm going to go ahead and put sine squared, tangent squared. Now, I'm going to start manipulating this side. I'm going to tell you why. Once you get a fraction over here like this, sometimes it's a lot easier when you see a tangent squared like this. When you think about it, it'd be a lot easier to make a substitution like this. Watch. See this sine squared x right here? I'm going to put it over 1. And see this tangent squared right here? Well, tangent is sine over cosine, so tangent squared would be sine squared over cosine squared. Do you see what's happening? Look, I made this substitution for tangent squared. Now go ahead and multiply. Sine squared times sine squared would be sine to the fourth x. That looks like sine of 4x. Let's change that. Sine x to the fourth power over cosine squared x. And look at that. We did it, okay? So just one more to go, and then we'll talk about the homework. Let's go on to the next one. Okay, there we go. All right, let's take a look at this problem here. Now on this problem here, again, I really just don't want to get into teaching you do this, do that. I want to tell you why I'm doing what I'm doing. Now when I look at this problem here, I say to myself, you know, I've got one fraction over here, and I've got two terms over here. If I can somehow rewrite this as a fraction and this as a fraction, and then put them together, get a common denominator, and come up with one fraction. Remember way back here in this other problem that we did, way back here, when we had one fraction on one side and one fraction on the other, we could cross multiply. Well, maybe we can do that if we can somehow get one fraction on one side and one fraction on the other. So what I tried to do was this. I saw cotangent. I said to myself, okay, cotangent is the same thing. I'm going to use x instead of this Greek symbol. It's a little easier. Cotangent is the same thing as cosine over sine. Look in your basic trig identities and you will see that. Now cosecant is the inverse for 1 over sine. So look at that. That's really pretty nifty to use an 80s word. That makes it pretty helpful, because now my denominator is sine, my denominator is sine. I have a common denominator, so I can go ahead and put these two fractions together. So now I have cosine x plus 1 all over sine x. So look at that. We really did not have to find a common denominator. We already had one. So that definitely made it a lot easier. So now I can put my two fractions together. Now bring this fraction down. And now you have one fraction on one side and one fraction on the other side. So now we can go ahead and do what I was teaching you before, what I mentioned before. Now we can go ahead and cross multiply and set our products equal. Let's see if that helps, okay? Let's cross multiply right here, all right? Sine times sine would be sine squared x, okay? Now be so careful on this one, students. Cosine x plus 1 times 1 minus cosine x. First of all, this cosine right here, you've got to multiply the cosine times the 1, and you've got to multiply the cosine times the negative cosine. So cosine times 1 would be cosine x, and cosine times negative cosine would be negative cosine squared. Now you've got to take this 1 right here and multiply the 1 times the 1, and also multiply the 1 times the negative cosine. So 1 times 1 would be 1, and 1 times negative cosine would be negative cosine. So there we go. We did it. Now look what happens here on the right side. Watch this. We have a positive cosine x and a negative cosine x. They're going to cancel out. Now, if I rearrange these two and put the positive 1 first and the negative cosine squared second, like this, do you not remember what that equals right there? Let's go back a couple of pages here and look. Watch this. Remember when I took, maybe I erased it. I hope I didn't, but I think I might have. And that's too bad if I did. Yeah, it looks like I did. Okay, well, that's fine. Remember when I said one of your Pythagorean identities is sine squared plus cosine squared equals 1? And if you bring your cosine over and make it negative, sine squared equals 1 minus cosine squared. Okay? So we took a trig identity and we broke it up. So 1 minus cosine squared actually equals sine squared. And now bring down your sine squared, and we're finished. So the third problem was the hardest. The last two weren't too bad. And a lot of you, maybe all three of you, are following what I'm doing and you're understanding it. You're probably just kind of scared, and you're probably saying to yourself, I understand what he's doing, but I would have never thought to have done that on my own. And that's where that dreaded P word comes in, practice, which means homework. And that's just what you're going to have to do. You're going to have to really work on these and practice them and just kind of see how you do. All right? So let me put the homework up here for you. Now, the good news about this homework assignment, I've got a couple of some good news here. First of all, 3 through 29, of course, is 14 problems, which isn't too bad. But I know earlier, I'm not sure why I said this earlier in the video, because I knew I was going to do this. I said earlier in the video, if you'll go back up here to my announcements way up here, I said don't get behind, no quiz over the weekend, so don't get behind on your homework. I would encourage you to do your homework over the weekend, but I want you to know on Monday I'm not teaching a new lesson. Guys, I know what I'm doing and you're going to have to trust me, okay? If each of these problems take only 5 minutes, that's 70 minutes right there of homework. And I'm telling you right now, some of these could take up to 10 minutes each. That's 140 minutes. So I want to encourage you to work on this over the weekend. If you choose not to, that's up to you. On Monday, I will not be teaching a lesson. On Monday, you will watch this video. It will say this. It will say pre-cal. Then what do I always put? Oh, it'll say October 14th, and then it'll say homework. And it'll be your typical homework video that you guys have learned to watch down through the year so far. And it will be a video over this. And I'm going to post that on Monday. All right? So you're welcome to wait until Monday to work on this. I don't think that's smart. I'm telling you it could take you 2 hours. That's why I'm giving one whole class period for this, because normally on Monday I would teach for about 30-40 minutes and then give you homework that might take 30-40 minutes, which is about an hour and a half. So if this whole thing takes you an hour and a half or 2 hours, that would be a normal Monday. But you might want to make Monday a little easier by starting this assignment over the weekend on Saturday and Sunday. It's totally up to you. But either way, on Monday, there will be no new, I can write, believe it or not, my pen's messing up. There'll be no new notes, only a video to watch of me working this homework assignment out. Okay, that's all we're going to do on Monday. So start on it now, or do it over the weekend, or wait until Monday. That's totally up to you. Please keep working hard. Don't hesitate to call me or email me if you have any questions, okay? That's what I'm here for. I actually have one of the students are coming by today, Friday, to get some help, to ask some questions. So feel free to do that. Contact me if you need to, okay? All right.